considering the fact that excluding you and myself, we are I think 5 people right now. I think we give everyone maybe like 2, 3 more minutes just to wake up. Um, and if not, then we have a very intimate session. But you know, could be could be very nice as well. For everyone else, I'm gonna already post the link. I have a presentation and I have a GitHub repository with a Jupyter notebook. So I'll post those in the chat. So this is not necessarily meant to follow along, but it's just for afterwards if you want to kind of go through things again. So this is the presentation. And then I'll put the link. Put the link to the Jupyter notebook in here as well. Okay, so it looks like we're stabilizing at around 10 people. What do you say, Johannes? Should we get going? Or should we give
Yes.
people a few more?
Let's wait another 2 minutes. I think usually it takes up to 9:05 that people might join.
Perfect. We're not even close to the academic quarter yet. So
Exactly.
this is the first session in the morning. I can relate, definitely. Ah, cool. Yeah, it's filling up.
Doesn't stop.
Okay, I think we can maybe start, and then people can still join. And I think the website is very clear, so to catching up should not be a problem.
Yes, perfect. So then, yeah, just before we start, for the people who maybe joined just in the last few minutes, I have posted, I hope you can all see this in the chat, I have posted the link to the presentation, as well as to the GitHub repository where the code is hosted, it'll be showing. This is less meant for like a follow along, and it's more meant to look up the things later on. But yeah, just for the record, they're there. They're also, in case you are missing them, they're also in the description on the ECEMP for the skills workshop. All right. So without further ado, let me start. So I'm here this morning. Thank you very much for joining. I'm here this morning for talking about PyAM. PyAM is a Python package that you can use for analysis, validation, and visualization, and it is aimed at integrated assessment as well as energy system scenarios. My name is Philipp Hackstock. I work for IASA. I work there as a research software programmer. So the session goals, what are kind of the main points that I would like for you to take home? So the first point is that you should understand what even is PyAM. What can it do for you, and why might it be nice for you to use it? So you should kind of understand where in the tool chain kind of it fits in. Very important, of course, since we're talking about data analysis and validation visualization tool. Of course, we need some input. So we'll cover what kind of formats are supported. Of course, visualization classically means coming up with some kind of plot. We'll cover that as well. And then sometimes the results you want to use do some deeper analysis. So you want to do some time series arithmetic. We will also take a look at that. But before that, let's maybe address the first point, or let's kind of step back as to what kind of created the need for PyAM. And so you'll see here, this is all a little bit of a mess, and this is of course deliberate. So you have your model, you run it, or you get the results from somewhere else, and you need to somehow analyze the outputs. You might want to compare them. You might want to just have a quick sanity check. And if everything is all right, you want to, of course, create some cool plots and come up with a paper. Now, the tools that are out there, and sort of the problem that PyAM is trying to solve, is that either they are hardwired to a specific framework. So I'm sure that if you were working with a modeling framework, we have listed a few here. They a lot of the time have like built-in diagnostic tools. The issue is there that they are sort of intertwined with the tool itself. On the other side here, we have very general purpose packages. So if you're working in the Python ecosystem, that might be matplotlib and Seaborn. If you're working in the R ecosystem, that might be something like ggplot and Shiny. And on the same thing here for data manipulation, we have for Python, NumPy and Pandas. And for R, we have something called tidyverse. So now the idea of PyAM is to sit kind of in between. So the hardware tools are like integrated into the modeling framework almost, and the general purpose tools would require you to write a lot of code. And so PyAM sits somewhere in between, where PyAM is specific to the domain, in the sense that PyAM is specific to integrated assessment models as well as energy systems modeling. But it is not specific to one model. So it has a lot of the functionality that you would normally code up. It has already built in. Yeah, this is sort of the kind of the process that we have gone through and that I'm sure that you have gone through a couple of times as well. So let's say you have some scenario data, you have some output, and the common approach is you just write a few lines of code because you just want to check, I don't know, is all the data there? Okay, fine, you write those few lines. And then you want to check the next thing. And then your colleague comes in and asks an interesting question, so you code up a few more lines. And as you probably have all been there, that thing gets bigger and bigger and bigger and bigger and bigger. And you sometimes, and you perhaps want to do this for another project, so you copy and paste what you had from 4 months ago, and you can see where this is going. One or three sort of the core issues with that is that usually this is not version managed. Usually you just write a few quick comments, but it's not nicely documented, and perhaps most importantly, it is not tested. So if you don't have unit testing, you can very easily run into some kind of bug or some kind of issue that, yeah, at best just, I don't know, makes the plot look a little bit weird, but at worst produces wrong results. The risks are that of course, if you don't then publish the analysis script, that it can limit the reproducibility and the transparency of the results. That is not only an issue if you don't publish it, but also if you do publish it and the thing is like 3,000 lines long, people are not necessarily going to sit down and read that. Of course, risk of errors and bugs is always there if you're using just something homebrew. So you can see that there's definitely the need for a more standardized tool. The vision sort of that we have for the package is that it is, as I said, specific to the domain of integrated assessment as well as energy systems modeling, but it is model independent. And it should sort of streamline the process of analyzing and visualizing and processing the results. The design principles, sort of the first thing that I guess you should start at is if you want to have a common tool that is kind of a data-driven tool, you need a common input format, because if you don't have that, then what's the point of having a common tool? Then the next point is that we want to have model-independent standardized methods. Now, there might be methods that are specific to your model, and this is not the scope for PyM, but there are certainly a lot of analyses that you want to do with any kind of model. So this is what PyM covers, and then PyM also plays nicely because it has a modular architecture, so that you can kind of pick and choose the best bits if you want to integrate it into a larger, perhaps, processing or analysis workflow. The advantages is that it has a standardized interface, so it plays well with pandas and matplotlib. In fact, it uses those two packages already. We've poured a lot of time into the documentation. We have tutorials available. We have an email list as well as a Slack workspace. As always, you first want to have a thing that works, and then you want to have a thing that's fast. So for that, at some point, we switched from the implementation based on Pandas data frames to Pandas series, which gave a boost in performance. The nice thing is that with PyM, a lot of the complexity that just creates unnecessary confusion is kind of hidden away in the library, and the analysis scripts become a lot shorter and a lot cleaner to understand. What we also have is last time I checked, I think we have 96% code coverage, so the package is well tested, and you can with good confidence you can trust the results that come out of PyM. If that sounds interesting to you, let me switch to the advertising section of this presentation just for a very short time. We actually have two job openings. So you want to join the scenario services and scientific software team, this is the team that I'm part of. It's a team led by Daniel Hupman, who you might know. We have 2 open positions. The main sort of things that we concern ourselves with is we support the development of state-of-the-art modeling tools. We implement and maintain the database infrastructure. So if you've ever interacted with the Scenario Explorer, that's us. That's what we do. And then we also develop tools for working with scenario data, such as PyM, and more recently, the nomenclature package. I have linked both of those here in the presentation. You can find more details on the team here, and also link to the job description. We have a research software developer position open, and then we have a position for the MessageIX community manager as well as a research software developer. So the second position is kind of a hybrid in between. So if any of you is interested, then we would very much look forward to your applications. So now to come back from the advertising portion, let's talk about PyM in detail. But before we talk about PyM, let's talk about the data format. So the PyM package is built on the IEMC template. If you've ever looked at scenario data that came from a scenario explorer, such as special report on the 1.5 degree global warming or AR5, AR6, then you have perhaps seen this. So it is kind of a tabular format. It's a wide format. It has the dimensions of model, scenario, region, variable, and unit. And then for each year, it has a value. So this is kind of the core of the template, but we've extended it so that it now also supports sub-annual time resolution as well as a continuous time format. So this is perhaps more interesting if you are in the kind of the energy modeling sector. Nicely, this is compatible with common tools used, so it plays nicely with pandas. In terms of file formats, you can write it out as Excel and as CSV, as well as the frictionless data package. So it kind of interfaces very nicely with all of those. And you'll see here on the right, it is used by a lot of very high-profile projects. So if you choose to adopt to use this template for the input or the output for your model, you know that you'll be in very good company. Oops. Now, finally, to talk about PyM. PyM is a Python package. It is community-based. I'll go about what that means in a second. It's for scenario processing, analysis, and visualization. The main kind of use cases, as I've alluded to, data processing, which covers data input output, file conversion, aggregation, downscaling, as well as unit conversion. We have validation features for checking the completeness of data, and also to check like certain ranges. And finally, for the analysis and visualization, you can categorize scenarios, and we also have a plotting library built in. You'll find here the link to the original manuscript. Yeah. Now, what does the community part mean in terms of PyM? So what it means for us is that we're trying to create this community around the package, which means that the manuscript that originally was published is openly accessible, as well as the documentation. I have put all of the links here in the slide. We have a lot of tutorials, as well as a fully fledged API documentation. So the tutorials are basically aimed at the novice users, and then for the more experienced people that want to get the last little bits out of PyM. The API documentation is what I would recommend. We have a mailing list, so again linked here. It's done on groups.io. So if you just want to have sort of the broad overview, new releases, new features, questions, then you can join that email list. For the perhaps more interactive experience, I can recommend joining our Slack workspace. It has a help desk, so in case you are just getting started or you're an experienced user and have any questions, we would be happy to help you. And then finally, kind of in the user pyramid, if you are quite experienced and you would like to contribute, that is more than welcome. We host PyM on GitHub, and I've also linked the GitHub repository. So if you would like to contribute, open an issue, open a pull request, we would very much appreciate that. Now, I've been talking for 15 minutes. I would have a little bit of a break. Let's take 5 minutes maybe. Let's see what time it is. It's 9:22. So I would say we can meet around 9:30. If you have any questions already, I will hang out in the chat just for a little while. And if not, we can meet again at 9:30. And then we will go into the live demonstration and continue with more discussion. Okay, so the 5 minutes are almost up. There was one question by Johannes. There's a second package that we also developed just for a little bit of context, which is called nomenclature, which is used for scenario processing and validation, which you could also look up. We have a documentation on that as well. But the main point of the talk is PyM. One quick kind of administrative question, or one thing that I forgot to mention that perhaps is even more important now during the live demonstration. If you have any questions at any point in time, please make sure to interrupt me. This is supposed to be, you know, like a skills workshop. This is supposed to be a little bit more of an informal interaction. So please go ahead. On the technical side, is there something? I know that I think in Zoom you can like raise your hand or something like that. So perhaps the question towards Johannes, is there something like that here, or how would people pose a question other than in the chat?
I think the easiest is to just unmute your mic and ask the
Okay.
question, because I mean
Yep.
the idea is to have it interactive, or in the chat, of
Yes.
course. So yeah.
Yeah, perfect.
Unfortunately, there's no raise the hand, but it's fine.
Okay, perfect. So then, yeah, if you have a question, just unmute yourself and cry. Perfect. So it is 9:30 now, and I would say we can I would say go ahead with I'll keep an eye on the chat here at the same time as well. And I will fire up the Jupyter Notebook. I will make it a little bit bigger. I think this is kind of a nice font size to read. And yeah, I would say we can go ahead. So this is now the interactive part. I hope that most of you at least are familiar with Jupyter Notebook. If not, Jupyter Notebook is kind of an interactive way to use Python. It combines Markdown parts with actual code parts, and so we will go through a couple of the use cases with PyM. Yeah, since there are no questions, I guess we'll jump right into it. So just for clarity, this notebook is based on a presentation that that Daniel Hupman did for the Engage workshop, which in itself is based on the presentation for the modeling lab. And yeah, we're going to cover some of the most important parts of the PyM package. I've linked the slides as well again here, and since again we need some input data, the data that we use is from the NGFS scenarios, which some of you might be familiar with. Before we get into it, of course, if you want to use PyM, you first need to install it. There are basically 2 or 3, I suppose, different ways. PyM is available on PyPy, which is the standard package repository for Python. At the same time, if you want to stay up to date and get like the bleeding edge updates, you can also install it directly from GitHub. So the way that it works is whenever we have enough updates to the main branch, we create a new release. But if you want to have like the sneak peek of all the new features, then you can do that as well. Alternatively, if you are a Windows user or you just like using Anaconda, you can install it through Conda Forge as well. And already this is the first link. There is the read the docs page for PyM. I will reference this a lot because there's a lot of time that went into this, and it's quite good. So you can also install it through Conda. Right. First things first. Let's import PyM, and let's get started with just loading some data. So we have the tutorial data frame. We in the GitHub repository, you will see that there's a data file here. This is the data file that we'll be working with. What's perhaps instructive before we actually jump in there is if we just take a look at the data file, because I've been talking about like the file format and everything. So this is what something like that then looks like. So we have a model column, we have the scenario column, then the region is covered, the variable, the unit, and then you'll see here in kind of a long table, wide table format, pardon me. We have all of the data here that we will be taking a look at. Interestingly enough, you'll see here or down there, you'll see the data sheet, and then there's the meta sheet as well, which is where we have various different meta indicators that can be stored. Now, this is just like a column that says that we want all of the scenarios when we read it in by default, but there's also more information that can be stored here. This is why we would recommend using Excel over CSV, because of course Excel gives you the option to have these multiple sheets here, where one is for data and the other one is just for the meta indicators, as well as if anyone has ever worked with CSV files, you know that the kind of the delimiter options with commas and stuff like that can be a little frustrating at times. Right, now let's go back. Let's read in the data and let's see what we get. So, read in the data, and basically what it gives you is kind of an overview. So, gives you an overview. We have a total of 2 different models. We have message and we have remind. We have a total of 4 different scenarios. And then along the other dimensions, we have 6 different regions. We have 9 different variables. We have 4 different units, and we have 10 different years. Now, if we wanted to have a complete list of all of the variables, this is not super useful, right? Because it doesn't give you the full kind of information. So what we would do here is you have these attributes of the data frame along all of the different dimensions. So if you want to have the complete list of all of the variables, you could just do dot variable, and then here you would have finally all of the variables that are available. In a similar fashion, you could do the same thing with all of the models, all of the years alternatively as well. So you can see that it's quite nice to just get an idea of what the data looks like. Then you have the option to look at the scenarios as well. Of course, here we have those 4. If you want to get a very quick overview of what the data looks like, there are 2 different options. There is data.time series. Type that would make life a lot easier. So here we have the data in the white format. This is very close to what we have in the Excel sheet, and then it also has a .data attribute, which gives you the data in the long format. So whichever one is more convenient for you if you just want access to the raw data. What's also nice is if we look at the type, for those of you that are familiar, this is a pandas data frame. So if there's anything as we will cover, there's quite a lot that PyM actually does for you. But if you ever need functionality that's outside of that, either we're of course always happy for contributions. The GitHub repository that I alluded to, but if you just want to have some quick additional functionality, you can always get your hands on the raw data using this option. All right. One of the first things that we will have to do, as you see, there are a lot of regions here. The remainder of the scenario, let's exclude all of the R5 comparison regions, and let's just focus on the world region. Is that a question there? No. Okay. So first, we use the filter function. This is a link to the documentation. So you will see here the filter function return a copy of a filtered data frame. So you can basically slice along all of these dimensions. So if you only want a certain model, if you only want a certain number of years, maybe, if you only want to look at a certain variable, then the filter function is your friend. So in our case, we want to just filter for the world region. Now, what is data if we can't visualize it? So first things we do, let's take a look. As we've seen up here, we have a couple of variables. Maybe the temperature variable is a good one to start. And we will just plot the temperature variable for all the different scenarios. So you can see that already per default, which is very nice, it it splits the plots into model and scenario combination. So you will see here that we have all of the message scenarios, then we have all of the remind scenarios, message models and scenarios, and you will see here the different values in degree of global warming for a given year. If we want to have this a little bit styled a little bit more nicely, because here, of course, if you want to check out which model is which, it gets a little bit complicated because you have to look at the legend all the time. We can specify here that we want to have a different color for each scenario and that we want to have a different line style for each model. So this is very convenient now because, as you will see here, all of the bold lines are for message, all of the dashed lines are for remind, and then blue is current policies, orange delayed transition, and so on and so forth. So now, if we compare this plot to this plot here, it was perhaps a little bit difficult to gain a quick insight what model kind of models which temperature for what scenario. Whereas here now it is a lot easier to see all of the bold lines here. This is message. For the current policies, we have the NDCs and so on and so forth. And as you can see, or as you would expect, perhaps, the kind of the pathways for the models for the same scenario, they're kind of roughly in the same order here, which is of course good, and this is already kind of a first sanity check, if you will, that this kind of lines up. One task, of course, that's always a good source of headaches and errors is unit conversion. We are working with physical units, and so if, for example, we want to take a look at primary energy, just a coal section for the message model for current policies, we can use the handy .time series that I've shown earlier, where we get the data in the byte format. We can see that the unit is exajoule per year. Now, if for some reason we don't like exajoule per year, but we would like to have petawatt hours per year, we can use the convert unit function. If we apply that, then we can see that all of the values for the primary energy coal variable are now in petawatt hours per year. In case you're curious, this is powered by the IAM units package, which is also a package that we developed that includes a lot of the modeling relevant variables. And of course, you'll see a theme here. I keep plugging the the PyM documentation a lot. We have a nice and detailed tutorial about that. So really, if you want to get started with PyM, definitely take a look through the slides again, take a look at the notebook. But really, what you can sort of rely on is that if you go to the documentation, the tutorials, there's a lot of good stuff here. So that should really be a good solid start for you to take a look and see kind of where this might fit into your workflow. Coming back, of course, if you have these kind of data, you might want to aggregate them. So in case you were paying very close attention to the variable list, we have a number of variables for primary energy, but we don't have the complete number for primary energy, right? We have the share of, or the amount of biomass, coal, gas, and so on and so forth, but we don't have all of the primary energy. Now, if we would like to do that, we have a function called aggregate. So in this case, we would choose the variable primary energy, and PyM is kind of smart enough to know that in the way that this variable hierarchy works, where you have these hierarchy levels separated by the pipe character. If we go up here again, we can see that you have primary energy pipe, indicating that this is like a subcategory. And then here we have in the subcategory the biomass fraction. Think of it as kind of like a nested list, if you will. So this can also then go deeper. Yeah, so if we want to aggregate that, we can simply compute df.aggregate primary energy, and as you will see, we now only have one variable because it returns only the aggregate by default. We will see how we can change that in a minute. And it does that already correctly for all of the model and scenario combinations for all of the years. Of course, we would want to visualize that. So right now, so then we could visualize for all of the different models, the different primary energy trajectories. Of course, if we would like to have this perhaps a little bit more cleanly, we could take the legend option and then have the legend on the side now. If you would have these time series in the wide format for all of the different models, you can also do that like this. So here you would have these values that you could then do some further analysis with. Sometimes what you want to do, as we've seen here, we've kind of lost every other variable. So what we can also do is we can just append. So the aggregate function has an append option, and if we do that, then all of a sudden, if we then simply look at the data frame, now the data frame has all of these variables, and if we explicitly want to list all of them, we see now that we don't only have all of the subsectors here, but we also have the kind of the primary energy sector. Now, perhaps one of you has already had this question in their mind, is of course, it doesn't only make sense to aggregate along the variable dimension, but it also makes sense to aggregate along the region dimension. What I mean by that is, if we come back to the example before where we had the R5 comparison regions, is the R5 comparison regions together make up the world. So what you could also do is, instead of aggregating along here the variable dimension, and in our case primary energy, you can aggregate along the region dimension. So this basically means that you take for one single variable in this case, so you would aggregate perhaps primary energy gas. You would aggregate this primary energy gas variable for all of the regions that make up, in this case, the world. This can be a very handy feature, especially if you want to compare scenario results from different models that have different regional resolution, right? So perhaps one model would parameterize Europe and another model would parameterize Western Europe, Eastern Europe, and so on and so forth. So with this aggregation by region, this is also covered. Again, the theme is clear. We have a tutorial for that. So this is for the aggregation on the spatial level. This is a very handy feature. Right, since I've been talking a lot now, I would again propose like a short 3-minute break. Perhaps you could grab a coffee, run to the bathroom if you have to really quickly, or if you have any questions. I will try and stay available during the the short break, so that we can talk about anything that's maybe unclear so far.
Can I add a short question, Philip? Sorry, hi, Hans here.
Sure.
On the aggregation of categories like the one you showed, is there two questions? So first, if there are several subcategories, let's say you would have coal also as kind of electric or non-electric, would that only then take into account not doing mistakes in summing, let's say double counting? I mean, that's kind of automatically taken care of, I assume, hopefully.
Yes, that should be taken care of. I will double check later. But yeah, I'm pretty sure that this is covered.
Okay, and the second question, I mean, sometimes there is, I think, the issue that some models might report maybe one of these over categories, and some others might be it's different. Or yeah, I mean, so what happens if, let's say, there were already one model reporting primary energy? I mean, yeah, would there be an error? Would it not work at all, or would it be overwritten? I mean, what is the philosophy there for to avoid, let's say, mistakes? Let's say you might report that primary energy total, whereas for the others would not be it. I mean, how you deal with this kind of issues in the data, basically, or it throws out an error, and if so, is it like easy to understand?
Yeah, very good question. It's a valid one, and definitely, I have to say, I'm not 100% sure, but the nice thing is that we can just try. So if we have if we look at the data frame here, we can already, so we have the primary energy included here, and then if we would filter for the variable of primary energy, and then get the time series, we can see what that would look like. If we would then insert another cell, use the aggregate function again, this time without the append, because we just want to have a look. Yeah, so we can see that it doesn't, basically, if we compare the numbers here and the numbers here, we can see that it definitely doesn't double count. How it works, if let's say a model reports it, if let's say a model reports both, I don't know if it's overwritten or if it takes the one that the model natively reports. I would have to look into that, but I'm sure that there's a sound logic behind it. But yeah, so to answer your question, the most immediate threat of sort of double counting, that one is taken care of.
Okay, thanks.
Francesco had another question: how to handle aggregation with variables containing subcategories that are not mutually exclusive. Oil, gas. Yeah, that's a good question. That's a very valid question. From my understanding, this would be there you would have to be careful in just setting up your variables. So PyM is not smart enough to kind of realize, okay, fossils can mean oil as well as gas. So if you report fossils as well as oil as well as gas, it will just sum those up. What you can do about that is you would create these subcategories, right? So you would create primary energy pipe fossils, and then you would have primary energy pipe fossils, pipe oil, primary energy pipe gas. So you would need to be careful in kind of catching that error as you are setting up your variable list. Okay, perfect. Good. Then I think we can continue. I hope people have had the opportunity to have a short break. And we can continue on. So as I said, the aggregation by region is it's not covered here, but we have a tutorial for that. Now another very important part that you might want to do is you might want to categorize different scenarios. And the way that you would do that, or the way that you would kind of assign, if you will, like sticky notes, labels to the scenarios, is with something called meta indicators. So here you would create the meta category. The name of the category would be warming category. Is that a question, Roberto? You would create the category, you would call it warming category, and the above 2C group is the first that we would assign. This is the value that we assign to all of them. So this is kind of the default value here. Then we apply the categorize function. The categorize function we apply to the warming category column. And then we say that everything that's below 2C is supposed to be based on the criteria that the temperature it has an upper limit of 2 degrees. So if we kind of run through this, one of the perhaps the more useful things is that you can always write the data out to Excel. So this would be, let's call it data frame, warming category meta. Very important. We need the ending. So now that we've written it out, we can kind of take a look, so we can see what that would actually produce. So as expected, we have here all of these ones. And then now, if you see here, the exclude column is there from before, but now we have a new column called warming category. As I alluded to, they all kind of have the default value right now above 2C, which is of course not really useful because not all of them are above 2 degrees. So what we need to do is we need to use the categorize function. The categorize function, again, we select the meta column that we want to apply it to. We select the value to then insert. And then we do that based on some criteria. So if we want to do that here, then PyM very handily gives us the information that found 4 scenarios that actually never eclipse 2 degree, and it applied the below 2C label to them. So if we now take a look, you can also access the meta attribute directly. You can see that here now we have some that are above 2C, so this is kind of keeping the default value, and then we have some that fall below 2C. In our case, the delayed transitions, as well as the net zero would fall in this category. If we again come back to the writing out of the results here, we can write them out. And now if we take a look, also here, we now have the correct warming categories. For some are above 2 degrees and some are below 2 degrees. So that kind of worked as well. We of course want to yeah, we might want to plot that. So the nice thing is that before we used the color to indicate the different scenarios, and we used the line style to indicate the different models. We will still do that here. We will still use the line style to indicate the model, but now we will use the color to indicate the warming category. So if we want to do that, and we want to do it for the primary energy gas variable, then you can kind of see that now we're looking only at the above and below 2 degree scenarios. So this basically groups them together. And then it gives you a very quick overview how the different models parameterize the gas consumption for 2020 until 2100. What we have as well, what's quite handy here on the right side, we have these uncertainty ranges. So basically this means that if we take all of the above 2C scenarios for both message as well as remind, you'll see here there are 2 message scenarios, here there are 2 remind scenarios, then you will get a range of projections. And this kind of, we fill the area here, we shade it here, and we have an indication as well. Same thing goes for the below 2C scenarios. We also have kind of the shaded area here, and then we see that there is quite a large discrepancy in how remind and how message parameterize this. The filling is fill between, and the final ranges attribute is this here. Again, if we just go to the plotting gallery, where you can then kind of have a more detailed instruction. Here, this is another example of these filled in between lines. So if you want to have, if you want to get some nice plots and you want to get some ideas, the plotting gallery for the documentation is definitely a good place to go. Now, what if you want to do analysis that goes further than just what the model provides you? Let's say you want to calculate the differences or the shares of, in our case, in our example here, primary energy and primary energy coal. PyM can do that for you. So PyM has the option of algebraic operations, where we have add, subtract, multiply, and divide. And they all follow this syntax. So you have df dot, and then you do add, subtract, multiply, or divide. And you would then put A, B, and C there, where A is the variable that is left of the operator. The operator is defined by the method. So in the case of add, it would be plus. B is the option right of the operator. And then C is simply the name that we give the resulting time series. So if we want to compute the amount of primary energy that is not coal, we can simply do that like this, where we subtract from primary energy. So we subtract primary energy by coal, and we call that result the difference. If we want to give that maybe perhaps a more descriptive name, we could stick kind of within this pipe nomenclature. We could perhaps go for primary energy pipe non coal. So now, as per default, again, PyM has a lot of sensible defaults. It gives us the title here of the chart, where it tells us what region are we looking at, what variable are we looking at. Here we've toggled the legend to false. We can also just take that out to have a little bit more more information, or we could perhaps have the legend located at the outside of the plot so that it doesn't clutter up the view. Okay, there's something slightly wrong here, so never mind. Yeah, so this is a short illustration of an algebraic operation. If the differences are not exactly the best thing to go for, perhaps you would like to have a share. So here we have the share of coal. So as you can see that this is something that I guess intuitively, even if you're not familiar with kind of the orders of magnitude with the coal consumption, you can still see that, okay, they all started kind of a third or just below a third coal energy. And then for some of the scenarios, it drops down quite drastically. One thing to point out that which is quite nice is that using this IAM units package, which is built upon the Python package of Pint, PyM recognizes that, hold on, now we are actually doing division. So this means that we have units of exajoule per year divided by exajoule per year, which is a dimensionless unit. So PyM recognizes that and automatically here just puts value. You might put something like arbitrary units or something like that, or share or something like this, but PyM automatically recognizes that this is now a dimensionless quantity, which can be very nice, and it can be a source of nasty errors. So we've kind of taken care of that as well.
So I have a question.
Mm-hmm.
What if we want to subtract or do any algebraic operation on more than one variable?
Yeah, so you would do that by selecting. Are you talking about you want to do that for different
Let's say
variables,
I want to
or you want to
subtract
do
two variables from one.
That you would do by basically going an intermediate step. So you would have the first minus the second, and then the result minus the third. So what you would do is if you take away the plot option here, this again returns a data frame. So what you could then do is you could then take the second step.
Okay.
So if you have, let's say, something along the lines of a minus b minus c, which I think this is what you meant.
Yes.
This would be something like d. You would, for now at least, have to do it that in the first step you do a minus b is, call it e, and then in the second step you would do e minus c, which then would be d.
Okay.
The kind of the multi-step stuff is not supported right now. The nice thing, or the thing, is that if you want to do anything that's largely more complicated, is you can always kind of get your hands on the data that is underneath using this time series or this or the data attribute. So if you are hitting kind of the limits of PyM, then stepping outside and using something like pandas is always an option as well. Yeah, so now what we've done so far is we've only done the algebraic operations on the variable axis, but you can do this on any axis. So kind of in a similar way as before, we were talking about aggregations that you can not only do on the variable level, which is the default, but also on the region level. You can do these algebraic operations on any axis. So if we take the data frame and we only take the primary energy variable, or we take all of the primary energy variables for for remind, let's run this, and let's also shortly visualize what that means. So this means that now we only have the remind model left over. We have still all of the 4 scenarios, we have all of the data, and we have a grand total of 7 variables. So if we do variable, we can see that this includes all of the subcategories that we read in, as well as the primary energy which we computed. So moving on from there, we can divide the net zero values, 4 in our case, all of these energies, by the current policies values. We call that the ratio, and we do that along the scenario axis. So what that gives us is it gives us the ratios for all of these energy variables in a sense of how much, what is the factor between what we need to achieve in the net zero and where are we currently at. And not surprisingly, the net zero scenario requires us to use quite a lot of non-biomass renewables, quite a lot of biomass, and quite less coal and gas and oil. So these is kind of a nice thing as well, where you can visualize the differences between the scenarios. So not only between the variables, but within the scenarios as well. We have one final illustration prepared for you, where we're going to do multiple plots, and this is kind of to see how, in the same sense as if you have something that in functionality goes outside of PyAM, you can use pandas. If you have something that goes outside sort of the plotting capabilities that PyAM natively has, you can always use matplotlib, which is the plotting backend anyway in there. So what we're doing right now is we have a baseline where we're again kind of looking at doing a ratio of different scenarios. We want to have current policies as the baseline, which makes sense. We want to do this for every scenario except for the current policies. We know that we want to have the number of subplots should be equal to the number of scenarios excluding current policies. All the y-axis should be the same. And then we simply iterate over the scenario. So what this then does is we have the division operator. We divide the current scenario. So for example, the net zero, we divide it by the baseline. We call that perhaps ratio is a little bit more fitting. We do that along the scenario axis. And then for the plot, we set a few parameters. And here, if you use keyword arguments, they are being passed on to matplotlib. So if you're familiar with matplotlib, this will look very familiar to you. We're basically iterating over the axis object that we get back up here, and we simply assign. So we assign the first graph goes onto the first object, the second graph into the second, and so on and so forth. And then we have the legend. The legend we only really want to put for the last one because it all has the same colors anyway, and otherwise the plot would be horribly cluttered. And then the titles. So as you've seen here, we kind of always so far left the default titles. You can of course also interface directly with matplotlib and set a custom title here. So now if we run this, we get we had 4 scenarios in total, minus 1 baseline. So we have 3 scenarios remaining. So we have the share of all of our energy variables here for the net zero target, the delayed transition, and the nationally determined contributions in relation to the baseline scenario. So this is essentially the same plot as we had here, where we had net zero versus current policies, you'll see this looks the same. And then we can also do the same thing for delay transitions and for NDCs. Yeah, so this kind of concludes the plotting part. I would say that we take another 3-minute break, or I guess 2 minutes, until 10:15, and then I have one final little nice piece of information for you, which is how you can retrieve data directly from the Scenario Explorer. Because so far we've been working with a downloaded Excel sheet, but you can also directly get the data from us. So in case you have any questions, please post them in the chat or just ask them. I will be away for just a second and then we can continue in 2 minutes. So I'm back again. I see that Johannes had another question about the colored ranges. Let's take a look at that. Here, the colored ranges. So the way that the logic behind this is that it's based on the color attribute, if I read it correctly, where the color attribute is the warming category, and so the warming category is kind of as we've set it before, it's a combination of, for certain models, for certain combinations of models and scenarios. So in this case, yeah, if I read it correctly, I can confirm later. But I'm pretty sure that the warming,
Right. Okay.
the
Yeah,
color
thanks.
and the fill between.
Okay. Okay, so blue is just above 2 degrees. Yeah,
Exactly.
just wide range. Yeah. Okay,
Exactly.
nice. Okay, thanks.
Let's go back here. So if there are no further questions, I would go over to the final part. So then we can go to the final part. So I'm sure, or I would hope that you have interacted with the Scenario Explorer before. For anyone of you who hasn't, this is an example. This is the one for the AR6, or the IPCC 6th assessment report, which contains a lot of very, very interesting data. There's a guest login option, which we would like to use, and then you see that there's lots of different analyses here already. And if we want to work with this data, we basically have two options. So the first option, let me increase the zoom a little bit so it's nicer. The first option is to go through the downloads, where you can just download the complete file. Again, very similar to the format, or in the same format that I've shown with the NGFS data. But there's another option. Going back to the notebook, there is this YASA connection object. So open a connection here. It already recognizes that I'm logged in, and then I'd have to consult the documentation for that. The valid connections is the kind of the list, because of course we would need to know basically what the AR6 database is referred to. There's a lot of different options here for me, but here is the one that we want. So here is the AR6. So we can then, as a next step, open the connection to the AR6 database, which tells me that I'm connected to the Scenario Explorer, to the AR6 Scenario Explorer, using my username. We can see how many models we have. Just the head function, if you've ever used Pandas, gives you the first 5 objects. If we don't use the head object, we get considerably more. So we have a total of 192 models in the modeling exercise for AR6, and the same we can do for scenarios and for any other dimension. So here we have a total of 1,418 different scenarios. Now, if we want to get some data, there is a very useful function called read EASA, where we tell it what is the database that we want to read for, what is the model, variable, and region. You can also filter, of course, for other dimensions. You can filter for scenarios as well, but let's not do that right now. And since I don't know exactly what the message model is called, or I want to have all of the results for message, I can put the star as kind of the match all character. And let's say we just want to have the CO2 emissions and the primary energy coal, just as an example, so that the download goes rather quickly. Again, it tells me that I'm downloading data from here. Download is already done. We can inspect what we have. So it seems that, okay, there are 5 models that start with message IX. So this is what the wildcard match here produced. We have, as we expect, one region. We have all of the scenarios that are available for this message model. We have 2 variables because we specified 2 of them, and we have them for all the years that it is available. So at that point, you could then basically run through the same exact kind of notebook steps that we've done before. You can visualize, you can assign ranges and stuff like that. You can create plots. Just this is kind of an alternative version how you can get data directly from the Scenario Explorer. You can then save them locally also, of course, and then keep on working with them. And as always, there's a PyM tutorial for that. So there is a tutorial for reading directly from YASA data resources. This also covers, by the way, in case you are part of a modeling exercise where the access is restricted with a username and password, this is also supported. So for internal instances that are basically being used before data is being published, that works as well. And with that, I would I can only advertise the docs again. There are all the PyM features in there. I've posted the link in the chat. I can do that again to the presentation, as well as the GitHub repository with this same exact notebook, so you can play around with that. And with that, all that's left for me to do is say thank you very much for your attention. I'll repeat the little plug from before in case you find these subjects interesting. We would very much look forward to your applications. So as I said, we have two open positions right now. I see there might be. These are all the questions. So I think we have about 7 minutes. So either there would be time for additional questions now, or we can end the session a tiny bit early.
Well, let me start by saying thanks a lot, Philip. I mean, a really great introduction, and a lot of work that went into this by all of the guys. I think a very, very useful and clean way to looking at data indeed. So thanks for dedicating the time also for this presentation. Yeah, please. I mean, as Philip said, post a question if you have any or question. If I can, maybe one short question on the AR6 that you showed, which I think is really very nice to have this accessible data for basically everyone. One question I have there is on the selection of scenarios. So because it's always when we try to replicate, let's say, figures or insights from the AR6, how, because there are so many scenarios, right? I mean, I think if you check in total, there's over 3,000, and then in the main AR6, at least working group 3 report, there seem to be 1,202, if I'm not mistaken, which had. So, I mean, it must be based on some metadata. So is it easy to be sure to use exactly the same set of scenarios that went into the AR6 figures within PyM? So, I mean, if I read the paper by Daniel and others, it says 1,202, I think. So, I mean, I wonder just how can you easily select the set that has been used for the main figures and all the analysis in AR6? I don't know I know it's maybe a bit technical question, but unless there are others for now, if there's an easy way.
No, it's a very valid question, of course. And I don't know the paper off the top of my head right now, but I would guess that somewhere in the caption or something it would say hopefully the scenario name, and so then you would either already put it here where you basically only download what you have, which would be in the interest of keeping things moving fast, or you could then use the filter function. As to how exactly you would find out which one was used if it's not given there, as always, my answer would be to reach out to the authors, and I'm sure they'll have the answer ready for you.
Sure. Okay. Yeah. No, it's a lot of data, and many filters have been done on different vetting and criteria. So, yeah, but I think that's best to get in touch with Daniel and others. Great. So the links are there and also on the website. And as I said, I mean, there's also the recording going to be available in a couple of days' time for everyone else to use it.
Yes, perhaps one last thing. Sorry if I interrupt you. The presentation is licensed under Creative Commons 4.0, so feel free to use it, to reuse it, to do everything within the licensing permissions, as well as the notebook and the GitHub repository is licensed under MIT, so you can also quickly look up the rights that grants you. But the short of it is the rights are very liberal, so feel free to create a fork. Feel free to play around with it on your own. So we're trying to make everything as open and accessible as possible.
Great. Excellent. Yeah, that's I think also very important for future contribution and free development. Great. I think it was very exhaustive and maybe a bit exhausting to see it very fast, but it's very, very easily usable, I think, and very easy to get also nice analysis and plots already. So yeah, I mean, in 2 minutes, I think we're going to start the plenary of today. So maybe it's also a good moment to have just step away from the PC for 1 or 2 minutes and then rejoin on Zoom. Actually, the link is on the website. So yeah, I think then thanks a lot, Philip. Again, really great presentation and an interactive presentation, and soon see it furthermore in the future. And see you over at the plenary then. Thank you.
Yeah, thank you, Philip.
Yeah, perfect. Thanks, everyone.